Okay. Say I give you this basic problem. Okay, basic problem. How do I solve for x?
Square root.
Can't take the square root.
Okay.
You can put it into a log form.
You can put it into a log form, or you can, we could do a log form, or common base. I heard common base. Can I drop 8 to a base of 2?
Yeah.
2 to the third. So when the bases are equal, then the exponents are equal. Okay. I also heard someone say we can put it in log form. Now, you have one rule that you learned. That's your power rule. Your power rule is the one rule that will bring down an exponent. And the only reason why you bring an exponent down is because it's a variable. And you need to solve for that. So the only thing that will get this guy to come down is if we have the word log there. Otherwise, we can't use the log rule. So because this is an equal sign, you can take the log of both sides. Because it is an equal sign. If you take the log of one side, you take the log of another side. If you take the square root of one side, you take the square root of another side. What you do to one side, you do to the other. You can also, in this case, take the ln of both. Now, because we have the log there, now we can apply your log rule and bring this exponent down. And now, this is multiplied. Don't separate your log words. Divide by log 2. Now make sure in your calculator, it's going to give you a parentheses that you close it, and don't reduce 8 and 2. That doesn't work. You have to say log 8 divided by log 2. And it should come out and say 3. X is equal to 3. Because the only rule that will bring that exponent down is your power rule. So somehow we have to get it to say log. Now if you use the ln, ln works the same way. Divide by ln 2. This will work the exact same way. You will get 3. If you can put them in the same base, don't go through the trouble. If you feel like as soon as you see an exponent, take the log of both sides, take the log of both sides. Whichever one you feel. Sometimes you won't get a choice. Like if I say 2 to the x equals 7, you really don't get a choice because there is no base for 7 that will give me a base of 2. So in this case, you have to put the log in front of both sides. And you have to bring the exponent down. Once you bring that exponent down, you can solve for it. Okay? At any point, you can choose an ln over a log. At any point, you can always use an ln. If it's an e base, your base e, then you cannot use log. You have to say ln. But ln will go for anything. That's why a lot of like the college books and the college courses, they just use ln for everything. What I do is I kind of interchange them so that you can see you can use both. ln, probably one less letter to write. I don't know. Maybe that's why people use ln's more than not. But this is basically why we use your logs, to get the exponent down so we can solve for this. Now, in this case, we have base e. This is your natural log. In order to bring the exponent down, we still need to use your power rule. We have to put a log in front of it. Well, base e can only use the natural log. So we put ln e to the x, ln 72. Now, your ln and your e key are located in the same place. Your log and your 10 raised to the 10 power is located together because your log is base 10. Now, if you remember back, we said whenever you have ln and e together, they cancel out. Their property is 1. So we bring down the x, whether you bring it down here, wherever, and it just is this. Now, just put that in your calculator. ln 72. And generally, again, round 3 decimal places.
What do you mean by ln?
ln is right under the word log. See on your left-hand side, you see log, and then you see ln. And look right above the ln, that's the e. See it? So the natural base stays with that. Now, when we do this, give me 3 decimal places. You can absolutely check this by using your e. Okay? If I check this, e to the x, I plug this in for here. Now do second ln. It already raises it if you have the software. If not, it gives you a caret and a parentheses. It does this if you have the old system. Just put that in, and you should get very, very, very close to 72. How come we don't get exactly 72?
Because you rounded the answer.
Because we rounded. If you want to get really exact, as soon as you do this one, ln 72, second answer. Raise to the e and do second answer. It pulls the whole thing in as an irrational number. And then it gives you exactly 72. But we know for ourselves that we checked it and it looks good. How else would I ever solve for that? It'd be a long guess and check, wouldn't it? Well, the only way to do it is to bring that down with a log statement. I'd have to spend a long time guessing and checking if I'm making you go to 3 decimal places, right? So, remember, in order to get your variable to come down, you have to take the log of both sides. Alright, let's try another one. Okay. Before we do this guy, we have to isolate this. Yeah, we're going to subtract 5 from both sides. Now what? We're going to do the log first. ln. Give me the ln first. Make sure both sides get an ln.
Then you can cross out lne.
Cross out lne. Good. And then let's do this to 3 decimal places. Good. 4.007. And go back and check it. E to the 4.007 plus 5, we will get approximately 60. We round it. If you want to use second answer, you will get exactly. But if you want to just be close enough to make sure that you're in the ballpark, round it. Make sure you kind of bring it out there because it leaves it in the numerator. Okay? Okay, any suggestions for number 3? You can divide by 4. What if I didn't divide by 4? If I take the ln of both sides?
Can't you separate the ln by doing ln 4 plus after?
Could I do that too? I could do that too. So you have a couple of choices here. If you divide by 4 and you can get away with it, that's fine. We'll do it both ways, and we'll see if it works out the same. So we've got e to the 2x, and you could leave it as 5/4, or this one works out to be 1.25. You could leave 1.25. Now, take the ln of both sides. This is coming out. So you're going to get 2x. I'm going to just bring it up here. Or 1.25, whatever you did. So now what do I have to say? How do I solve for x? Divide by 2. Okay. So let's see what you get. Be careful with your parentheses. One, 2. Good. So let's try plug this back in. 4 times e to the 2 times this. And see if we get approximately 5. Get approximately 5? Close enough? Now, Erin told me another routine. Erin said, what if we took the ln of both sides, we come back up here, and we use, what rule can I use on this left side? So you turn it into an add when you're multiplying like bases, right?
Yeah.
So we're going to add this. So let's see if this works for us. This comes out. Subtract ln 4 from both sides. And then what? Divide by 2. Now be careful. This has to be in parentheses. Anytime you have a grouping in your numerator or your denominator, make sure you put parentheses. And don't forget with the logs, it gives you another parentheses for your number in there. So put that in, see if you can get that in there, and see if we come out the same way. Comes out the same? Okay. So you have a couple of choices here. If you can isolate that by dividing it out, you can divide it out. My advice is, if you divide this out like over here, leave it as a fraction. This one goes nicely into a decimal, but if it was 5/3, you can't round that. You're going to get a second rounding error in there. So I would just leave them as a fraction if you're going to do it that way. Yes? Because you have to do the ln first. Do this first, and then divide by 2. See the difference? You're taking the ln of this, and then you're dividing by 2. Yeah, don't divide the whole thing. This says do this part first, and then divide by 2. Okay? Okay. See what else we got here. Now, because we can put logs on both sides, we can also take logs away from both sides. But they have to be on both sides, and they have to be one term, one term. We have 3 basic type equations. That one that we just did where we put the logs there. This one, where we just have one ln. If you only have one log statement and it's not on both sides, you can't take it away. You're probably going to go back to an exponential equation. So let's talk this one for a second. Remember how we expanded your statements and then we condensed them? Anything in front of the ln, it has to have 1. So where did this 2 come from? Ah, the exponent. So it started out looking like this. Okay? Now, let's isolate this guy. Let's isolate it. Subtract 5. I cannot take the ln away from this because it doesn't exist on both sides. Alright? What's this base over here?
2 times. Oh, it's not that.
No.
1.
On a log, it's 10.
Is it 5?
What's the base on a natural log? E.
Oh.
It's an E base. So E to the negative 1 equals x squared. This is a horrible example.
Oh. Wait. So
We flipped it around.
So how didn't you just drop the ln?
We didn't. We didn't. We converted it to, we converted this. What's the base of this log? E. What's the exponent?
Yes, I just cross out ln.
So it doesn't work.
Yeah, I'm flipping it around. I flipped it around. If I did this, if I raised both of them to the same side, you can't just put this in here. If I did this, then I can cross that out. But I'm just flipping it back. I should have done one with a log in it rather than an ln first. So here's your exponent, x squared. Now, what is e to the negative 1? Does e to the negative 1 work? Use your second key. Okay? This was a terrible example to use because you really can't see much from this. So e to the negative 1 is this guy. Blah, blah, blah. And then I would have to take the square root of it. Okay? I must have left something out of that example because it shouldn't have come out this badly. Shouldn't have come out this bad. So x is about 607. Okay, now try it back in there. We'll do more, and they'll make a little bit more sense. But try this back in there first. Just plug it back in and give it a try. So you come real close to the 4. I realize this wasn't the greatest of examples to use, but I probably left out something in there. This one will hopefully work out better. Okay? Now, you can raise both to the e. The ln's work a little bit different. Let's try another one. Maybe I'll take one of your homeworks and try that too. Now, here's another situation, guys. I have ln's all over the place. Okay?
We're going to find the concept.
Well, we're going to bring it down to say ln equals ln. We're going to use your rules. So Aaron remembers when we added your exponents, what were we doing to your bases? Multiplying. So pull this out into one ln statement. Okay, what else am I going to have to do? Bring the 2 up. It's got to be a 1 out here. So bring this 2 up. Oops. Now, how many terms are on the left side of this? 1. How many factors? 2 factors, 1 term. Terms are separated by pluses and minus equal signs. There's 1 term here, there's 1 term here. When there's 1 term, you can take the logs away. Just as you put logs there, you take them away. The plus sign, we used our product rule. Our product rule said, you know how you separated them like this? We would have separated this into an add. We just condensed. We went backwards. We say, when we added our exponents, what were we doing to the bases? We were multiplying them. So it came back into a multiplication. Now, you've got this. Is this doable to solve? Yeah, it might not be the prettiest problem, but it's doable. So we solve. You combine your like terms. And we get everything to one side. Subtract the x squared. That's not so bad to factor now, right? We moved everything to one side. We got a quadratic. Put it in descending order. Good luck. So what is this going to factor into? X minus 6. X minus 1. Will that give us negative 7 in the middle?
No.
And plus 6 on the end? So x is equal to 6, and x is equal to 1. Now you have to go back and check. You cannot take the log of a 0 or a negative number. If one of these gives you a negative or a 0, you can't do it. So I'm going to check my 6. 6 minus 2, 4. That's good. 12 minus 3, 9. That's good. Let me check 1. 1 minus 2. Oops, that's a negative 1. See if you can do this. Put this in your calc. ln negative 1. What does it tell you?
Non-real.
Non-real. Where's your domain for your log? Where's your domain? From 0 to infinity. I know this feels like we did this like 3 weeks ago, I know. Even though sometime we did it like, yeah, we probably did with all the snow days. Yeah, we didn't have class last week. Yeah. Yeah. So if you remember, we can't take the log of a 0 or a negative. In this case, you have to say reject. You have to say reject for this. All right, I want to take one. I seem to have all logs here. Questions on these? No? All right. I want to take one from your homework. 1 or 2. Let's take 1 or 2 from the homework. Let's take a look at number 3. Now, this has only one log. Can I cancel out the log? No. If it had log on both sides, I could cancel out the log. But I can't cancel out the logs on this. So therefore, I use log equals exponent. I flip this back to an exponential equation. What's the base of my log? What's my exponent? Now I solve. Regular equation. 4 to the 3rd. And just divide by 3. They may not come out as nice numbers. Leave them in reduced fractions. Or if you want to, if this will make it check the best, if you want to, go to 3 decimal places if you're going to reduce it. Okay, so when there's only one log, you cannot cancel your logs. You got a couple of different types of equations. Take a look at number 1. Well, no, not number 1.
Number 6.
All you gotta do.
Okay, we'll get to number 6. We'll do number 6. Number 6, you could do a number of ways. Okay. If you can bring them down to the same base, can I bring 3 down, 27 down to a base of 3? Can I bring 64 down to a base of 4? This is your easiest way. Can we take a log of both sides? Sure. Let's do this one first. What's 27? 3 to the what? 3 to the 3rd. 64 is 4 to the 3. Now see, these both are the exact same. So you can take this out like this. Right? It's raising both to the 3rd. You can't do it if one goes to a second power, one goes to a 3rd. So now, when your base is the same, what's your exponent equal to? 3. Okay, but say that just so confused me, right? I really don't like that. How do I get that exponent to come down? Say that out. Okay, how do I get an exponent to come down? My power log statement, right? This doesn't say log. So I'll take the log of both sides. Now what? Bring the exponent down. You have a couple of choices. You can use your add rule in here. I probably wouldn't because you're going to get another set of parentheses. I would just divide by the log of 3/4. You're probably going to have to deal with a few parentheses in here, but that should become the same. The only thing that brings that exponent down is a log statement. If you put the log on one side, then you put the log on the other side. Yes? It's same if it was ln. I could take the ln of both sides. Absolutely. And then bring it down.
But number 9, would you just cross out?
Hang on. We'll get to number 9. Are we okay with this? Aaron?
Make that like log of 27 over 64 to the base of 3 to the 4.
Well, you can do it this way here. If you wanted to, you can expand this to do the log of 27 minus the log of 64, but you'd have to be careful and keep those in parentheses. You can do that. I wouldn't do too many steps because you get a lot of parentheses going on. The bad part about your logs too, it also gives you a parentheses in here. So you've got a lot of parentheses going on. If you can leave them as a fraction, then that's probably better. Okay. Number 9, I didn't give you an equation. So number 9, I probably left something out. What happens to your ln and e? Just becomes x squared. Okay? For some odd reason, missing the equation. All right, let's take a look at number 17. Can I take the log away? It's base 10, but is it on the other side as well? Nope. So I have to flip this to an exponential equation. Now, this wasn't so bad because I can see the base. Don't forget, sometimes they don't put a base in here. If I saw this, what's the base? 10. So when I go to say log equals exponent, sometimes it's helpful to put the base in there. So 10 to the 2 equals z minus 3. Is that solvable? Right? Okay, if you have one log, remember, flip it back to an exponential equation. If it's logged on both sides, get it till it says log equals log. Right? Anything with the power exponent, make sure you move it first. So you're going to do the rest of these for homework. And then